Analytical chemistry is a branch of chemistry that focuses on the development and application of methods for chemical analysis. It involves the study of the chemical composition and properties of substances, as well as the development of techniques for measuring and quantifying these properties. Analytical chemists use a variety of methods and instruments to identify and measure the components of a sample, such as its chemical composition, concentration, and purity. Some common techniques used in analytical chemistry include chromatography, spectroscopy, and mass spectrometry. Chromatography is a separation technique used in analytical chemistry to separate and purify components of a mixture. It works by distributing the individual components of a mixture between two phases, a stationary phase and a mobile phase. The stationary phase can be a solid, liquid, or gas that is immobilized on a solid support, while the mobile phase is a liquid or gas that flows through the stationary phase. The sample mixture is introduced into the mobile phase and it flows through the stationary phase, where the individual components of the mixture interact differently with the stationary phase and the mobile phase, causing them to separate. There are several types of chromatography, including gas chromatography, GC, liquid chromatography, LC, and ion chromatography, IC. In GC, the stationary phase is a high boiling point liquid that is coated on a solid support, and the mobile phase is an inert gas that carries the sample through the stationary phase. In LC, the stationary phase is a solid or liquid that is packed into a column, and the mobile phase is a liquid that carries the sample through the column. In IC, the stationary phase is an ion exchange resin and the mobile phase is a liquid that carries the sample through the resin. Chromatography is widely used in the chemical and life sciences for a variety of applications, including the analysis of complex mixtures, the purification of individual components from a mixture, and the isolation of bioactive compounds from natural sources. The development of new chromatography methods and the improvement of existing ones is an ongoing area of research, with the goal of improving the speed, efficiency, and sensitivity of the technique. Spectroscopy is the study of the interaction of electromagnetic radiation with matter. It involves the use of various instruments to measure the absorption, emission, or scattering of electromagnetic radiation by matter. The interaction between electromagnetic radiation and matter provides information about the chemical composition and structure of the sample being studied. There are many different types of spectroscopy, each of which uses a different region of the electromagnetic spectrum. Some common types of spectroscopy include infrared, IR, spectroscopy, measures the absorption of infrared radiation by molecules. It is used to identify and quantify the functional groups present in a molecule, as well as to study the conformational changes in biomolecules. Ultraviolet visible, UV-vis, spectroscopy, measures the absorption of ultraviolet and visible radiation by molecules. It is used to identify and quantify the presence of chromophores in a molecule, such as conjugated double bonds or aromatic rings. Nuclear magnetic resonance, NMR, spectroscopy, measures the interaction between nuclear spins and an external magnetic field. It is used to study the structure and dynamics of molecules, including proteins, nucleic acids, and small molecules. Mass spectrometry, MS, measures the mass-to-charge ratio of ions in a sample. It is used to identify and quantify the components of a mixture, as well as to study the structure and dynamics of molecules. Other types of spectroscopy include X-ray spectroscopy, Raman spectroscopy, and fluorescence spectroscopy. Spectroscopy is used in many different fields, including chemistry, biochemistry, physics, and materials science. The development of new spectroscopic techniques and instrumentation is an active area of research, with the goal of improving the sensitivity, resolution, and speed of spectroscopic measurements. Mass spectrometry, MS, is an analytical technique used to identify and quantify molecules based on their mass-to-charge ratio. In MS, a sample is ionized, meaning that its molecules are converted into charged ions. The ions are then separated and detected based on their mass-to-charge ratio. The process of MS involves several steps. First, the sample is ionized, typically by a process such as electrospray ionization, (ISI), or matrix-assisted laser desorption, ionization, (MALDI). This converts the molecules in the sample into charged ions. Next, the ions are accelerated in an electric field and then separated based on their mass-to-charge ratio by a mass analyzer. There are several types of mass analyzers, including time of flight, TOF, quadrupole, and ion trap. Once the ions are separated, they are detected by a detector, which measures the number of ions of each mass-to-charge ratio. The resulting data is typically displayed as a mass spectrum, which shows the relative abundance of ions as a function of their mass-to-charge ratio. Mass spectrometry is widely used in many different fields, including chemistry, biochemistry, and materials science. It is used to identify and quantify the components of a mixture, determine the molecular weight and composition of a compound, study the structure and dynamics of molecules, and identify and quantify small molecules, such as metabolites, drugs, and environmental pollutants. The development of new mass spectrometry techniques and instrumentation is an active area of research, with the goal of improving the sensitivity, resolution, and speed of MS measurements. Analytical chemistry is used in many areas of science and technology, such as environmental monitoring, food analysis, forensic science, and pharmaceuticals. The development of new analytical techniques and instruments is an ongoing area of research, with the goal of improving the accuracy, sensitivity, and speed of chemical analysis.